So as we watch the experiment being set up, let's take a note of what exactly is going on, what exactly a thermite reaction is. Thermite is made by mixing iron oxide and aluminum powder and igniting them at very high temperatures, usually a few thousand degrees. The reaction releases a lot of energy, and molten iron metal is produced as one of the products. Now let's take a look at the equation of this reaction. Fe2O3 plus 2Al results in Al2O3 plus 2Fe. So this equation is essentially derived using the single replacement technique. The metal reacting with the metal oxide must be significantly more active than the metal oxide to support this single replacement reaction. It's very essential to look at the left side of this equation and the reactants in this equation. Thermite is not easy to ignite. Thermite has a very high activation energy required to start the reaction. One can use potassium permanganate to do this, for example. Once the activation energy is provided in the form of heat, the reaction becomes self-sustaining. Iron oxide is essentially rust, which oxidizes very quickly and contributes to the reaction significantly. Now let's take a look at what actually happens when we throw all these things together. The aluminum is more reactive than the iron, so it pinches the oxygen from the iron to make aluminum oxide and iron. Since the thermite reaction is exothermic, it releases energy. If you stand a couple of feet away from the reaction, you can actually feel the heat radiating outwards from the reaction. So since the heat is being released, the enthalpy change within the system is negative. Just to take a look at how strong this reaction really is, take a look at the pot. The pot, which the reaction took place in, on the inside, is actually broken. This shows that this reaction indeed does involve a lot of energy.